I'm Kirk Harnack. On This Week in Radio Tech, I'm joined by Chris Tarr, Chris Tobin, and Barry Thomas. It's a War Stories episode complete with transmitter sound effects. TWiRT is up next.
Netcasts you love.
From people you trust.
This is TWiRT.
Bandwidth for This Week in Radio Tech is brought to you by CacheFly at CACHEFLY.com.
This is This Week in Radio Tech, episode 100, recorded September 21st, 2011. Thwap, thwap, thwap. This Week in Radio Tech is brought to you by Omnia Audio and the new Omnia 9. Multiple processors in one box to get the job done, and a feature list as long as your arm. Check it out at omniaaudio.com/9. It's time for This Week in Radio Tech. Hello there, I'm Kirk Harnack, your host. Glad to be here. Founder of the show. I'm the guy that talked Leo Laporte into letting me do this. So I'm glad you're along for the ride. Got a couple of great co-hosts with us. Tom Ray, one of our usual co-hosts, is not with us tonight. He couldn't be here, but he'll be back maybe next week. On the show tonight, the best-dressed engineer in radio from Manhattan, New York, it's Chris Tobin. Hi, Chris.
Good evening, everyone. How is everyone doing? Well, I hope. Barry and Chris and Kirk. I was with the CBS folks and started a new career, moved on to folks at Musicam USA. So, full disclosure, we're a company that produces codecs for audio over Ethernet and video over Ethernet. So, you hear me talking about those technologies, that's just in the general terms. But if you want to know more, you can always go to the website. That's it.
Actually, I've got a quick question about Musicam. Chris, it seems like some years ago I met a gentleman who was part of Musicam in the U.S.'s founding, and it was a Dr. someone. Do you know who I'm talking about?
Dr. Larry Hendricks?
Yes, Larry Hendricks. Yes.
Yes, absolutely.
He gave a talk at either an SBE or an NAB, something or other, and he was fascinating and well-spoken, and just gave a great paper, and it really helped me start to understand this world of codecs. And he may have been talking about something as nowadays relatively as simple as G.722 or maybe MPEG Layer 2. This was a long time ago, but I sure appreciated the talk that he gave, and it kind of got me on my way to understanding what psychoacoustic coding is all about.
Yeah, I was actually talking with someone today about Larry, and they were telling me a story that on a flight from the New Jersey to NAB, I guess it was Vegas, maybe it was Chicago at the time, he actually sketched out a working document for a ISDN codec they were developing. The time it took to fly out to the NAB, he actually put together a sketch and documents for the guys in manufacturing to actually put together a prototype. That's how much, that's how depth, how deep it was, if you will, in engineering.
You know, come to think of it, the first Musicam, or at the time CCS codec that I dealt with was at a Christian radio station in Memphis, Tennessee. We had one that had an external box that connected to a switched 56 line. It wasn't even an ISDN at that moment.
Yeah, actually the first boxes were for switch 56. Traditionally, you used the Inc. brand box. It was a huge square black box. And then years later, you'd use an Adtran 2x64 and put 2 codecs in each B channel and have yourself a fun time. But yeah, Switch 56, that was what started it all. And it was Larry and another gentleman by the name of Tim Chase, another software genius. He does a lot of stuff for the military now. But yeah, they just came up with some wild stuff, and we're just carrying on the tradition now.
Well, good deal. Glad to have you on the show. We're expecting a war story from you today.
Absolutely.
So, you know, be ready. Also with us from the burgeoning metropolis of Muckwonago, Wisconsin, it's Chris Tarr. Hello, Chris.
Hello there, Kirk. Hello, everybody. I'm the Director of Engineering for Intercom's radio stations in Madison and Milwaukee, Wisconsin. I also run the website broadcastengineering.info, the virtual engineer, and you can find me at thegeekjedi.com.
All right. Encourage people to go there to thegeekjedi.com. Hey, remember, we're running a little contest, and it doesn't do much good to talk about it at the moment. I guess we'll announce the winner at the end of the show. We're wanting, of course, to increase the number of folks who watch or listen to or subscribe to This Week in Radio Tech. So every week, an hour or two or a half hour or some time before the show, I've been tweeting. My Twitter handle is K Harnack, at KH. There you go, right on the screen, at K Harnack. And if you will retweet my tweet about the show starting, you're eligible to win an Omnia AXE. This is Windows software. It runs as a service, and it processes audio just right for audio streaming, and then it will also create MP3 streams, different flavors of AAC streams, and a number of different codecs are built into Omnia AXE. So you check it on the website if you want to at omniaaudio.com/AXE, and we're giving away another one of those on today's show. Now, let's check in with our guest. This is a guy, I've known this guy for, I'm afraid to say, well over 20 years, maybe? Quite a long time. It's Barry Thomas. Hey, Barry, how are you?
Hey, okay, I'm just trying to retweet here. I want to win that. How you doing? How you doing, guys?
I'm great. Barry, I met you. We were talking earlier. I guess it was in Memphis, Tennessee. You came driving by some radio station that I was doing the engineering at, and you had an entire audio console, a big honking Harrison audio console in the back of your van, and you said, Kirk, hi, I'm Barry. Come take a look at my audio console.
Yeah, you need to see this. And I remember your office, right outside your office, stared into this bank of transmitters. You know, the entire hallway was a set of transmitters. And I remember sitting at your desk and talking about consoles, and you telling me a little bit about the market.
Oh my gosh, I'm trying to. I'm not sure I'm trying to remember or forget that time.
Well, let's just say it was the awkward years.
That's right. That's right. So, and Barry,
and oddly enough, that was actually pre-mullet for me.
Oh God! I remember the mullet. I remember the mullet. Yeah. Gosh. Well, in the chat room, Dr. Balthazar says the AM years. And indeed, Barry, you and I were talking earlier about how we got started in radio. I actually got started in public radio, but then pretty quickly moved over to WEKY, Y134 in Richmond, Kentucky. And you were telling me you were at a station almost equally as small in Columbia, South Carolina. What was that about? How'd you get started?
I hung around this little disco radio station in 1978 and 1979, WXAP, 1230 AM. It became, and it was historically WNOK in Columbia, South Carolina. But at the time, it was a juking little disco radio station. But what did I care? It gave me a chance to work in there. But I remember the deal was I had a really nasty cold the first time I went in there, which was great. The program director asked me to read a couple of news stories, and hey, I got a weekend gig. Little did he know that my cold went away about a week later.
Okay.
But by that time, I had worked. You know, he figured out that I was good at pulling copy paper and setting up my Sunday morning religious programming.
Gotcha. So you get started on the air, but now you're an engineer. In fact, now you're with a big broadcasting company, Lincoln Financial. Tell us about what you're doing now, and then I'd kind of like to hear about the progression of weekend disc jockey to director of engineering for a big honking broadcaster.
Oh, we don't have that kind of time. No, yeah, I'm vice president of engineering for Lincoln Financial Media. We're a relatively small company nowadays. I mean, you compare Clear Channel, Cumulus, and those, but it's we're what used to be Jefferson Pilot, which a lot of you may remember them. But yeah, I started out on the air, but I found out pretty quickly that I actually wanted to make a living, and being on the air takes a certain gift, which I really, if I worked on, I might be okay at it. But I really enjoyed the technology, and that was something that came a lot easier. And although I would do whatever job that they would let me do, I was even talking to my first GM last week. Whatever place they would let me work, I would work and make myself indispensable that way. But all the while, I was the puppy dog assistant to whatever engineer that station had, so I could just pick up just about everything there was. And eventually, just ahead of a rebuild, they said, "Well, we're going to give you a shot at rebuilding this place," and they forgave me.
Now, it seems like when I met you, you were working actually for a dealer, a broadcast equipment dealer.
After working for this little group is a pair of stations in Columbia, South Carolina. And I remember in high school I had this this goal to be the chief engineer of WNOK AM/FM in Columbia, South Carolina. I didn't realize I was going to hit that pretty easily. I guess the bar was relatively low, considering that it was a small market. You could work yourself into that. But after doing a lot of work for that owner, doing some work in Kentucky, and building another station in Hilton Head, I decided to give broadcast sales a try. Just still trying to find myself. And I worked for Broadcasters General Store at the time. A lot of you may remember them, know of them from Ocala, but at the time they had sales offices in Carroll Stream, near Dallas and Arlington, and in Marietta, Georgia. So I worked in the Marietta office, and like Kirk said, I toted around consoles. In that case, I was carrying around either a Harrison Pro 790 or it was an AP 100. Full payback for having sold enough of those consoles. My next engineering job, I had a pair of those things I had to keep running. Don't want to speak ill of Harrison consoles, but every piece of equipment has its own unique challenges. And I always felt like that was my penance for selling those things, was I had to live with them for a few years.
You guys know that Harrison, now Harrison tends to build consoles for television, but for a while they built consoles that were intended for radio, right?
Yeah, they were actually a motion picture console company.
Oh, okay.
And they had great television consoles, but their core was motion picture and recording. And they had taken what was their premier recording studio product, the Series 10, and created a little microprocessor, actually the first microprocessor-based console in existence, called the AP100. The entire console set basically on a 6x6 square chip, board. Scared the heck out of anyone with regular who did consoles, because you'd have to reboot the console. But it was pretty fast, and considering the technology, it was incredibly advanced. And I remember Martin Burns was the main company sales rep at the time. I remember him talking about it. What the future of consoles would be is that they would be this rack in another room, and all you'd have in the studios would be a control surface. So how true is that?
Huh. That's that was different for that time, right?
No one was doing anything like that. Router-based consoles were still 15 years away.
Okay, so you said the right phrase there, a router-based console. Okay.
Right. So we weren't even thinking of a streaming technology console. He was just talking about a router-based console.
Yeah.
So this was the first step into that. But their predecessor to that was the Pro 7s and the Pro 790s, which doubled as VCA-type consoles, but they also made a really good fried egg.
I heard these were pretty warm. Now, you just used a phrase there. You said a VCA-based console. Tell us what that means, because the consoles that I started using, gosh, the first one was an RCA, whatever that blue and silver console was, and it had potentiometers. It had step attenuators, lots and lots of resistors, all built around these contacts, and the wipers were on the the back side of the knob, the other side of the front of the console, and they'd wipe these different resistors. And if you had a tone on the air, not that you would, but if you did, you would see it go, step, 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 step. It wasn't a continuous up and down. It was in, 2 or 3 dB steps or so. So that's what I got used to these. I think Davin was the company that made these step attenuators. Some consoles had potentiometers or pots. So what's a VCA?
Well, before I do that, there's a detail about the step attenuator console you're talking about. They would always get dirty, so it wasn't just step, step. It was step, 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 step.
Like left and right would be out of sync with each other.
Something like that, they went out of alignment. But those were really the thing about those consoles is you had a very consistent fader curve. They were very consistent sounding consoles, and they had good distortion characteristics. That's why our RCA built things that way. It was just that good. And I think you were talking probably about the BC6. But the VCA console was one that used a chip to vary the voltage, but so no audio was on the potentiometer itself. It would control a chip which carried the audio. So if it was dirty, you wouldn't hear it scratch on the air. It would just be a change in, it would either, skip a volume level. It was the 790 series, I believe, was the first time VCAs became low enough distortion that you could have a lot of them in a board and you wouldn't hear it. That was relatively recent. I mean, up until, I guess, the mid-'80s, low distortion VCAs were still very expensive. Pretty quickly, technology changed that VCAs weren't the way to go. By the early 90s, people were using DCAs, and it was a digitally controlled attenuator that would step in a digital fashion using a digital word in the on the pot instead of using a constant voltage. It would be a digital encoder that's a pot. All of those have advantages and disadvantages. But the thing about the Pro 790 and the Air 790 is it had a tendency to fail a certain way. When the VCA failed, it would fail all the way open.
Oh my goodness!
Yeah.
Okay.
So then all you could do to kill the audio was just turn on and off the pot.
Turn the channel on and off. That was going to be my next question. What typically was the VCA control separate from the channel on-off control?
Yeah, and you hope that you didn't lose control voltage and you actually could turn off the pot.
Ah, okay. Now, I heard that some of these early consoles that had DCA, digitally controlled amplifiers, had a problem where imagine that you had no audio on the console just so you could hear the small effects, that when you ran the pot up and down, it would sound like a zipper.
Absolutely.
Zip. Yeah.
Yeah, that's exactly what it would sound like, because this is early technology, and we're still figuring out how to make it work. And yeah, most of the time you wouldn't hear that, but if you were trying to run a real proof and you changed the pot, you'd hear that.
Oh, gotcha. Hey, we've been here jabbering, and I want to make sure Chris, hey, hello guys, are in on the conversation. I just want to point out that it seems like I used a pretty inexpensive console. It was I remember it was a Harris, or maybe a Gates Harris 5-pot stereo console. And honestly, this thing was pretty awful. It was just an awful little console. And the knobs were enormous, but the mechanicals of the pot itself was very small. And these were not step attenuators; these were potentiometers, and they would never track equally left and right. At two places, at the bottom and at some one given place where you would try to calibrate the other channel. And these would get dirty. You mentioned earlier, why do we go to VCAs, voltage controlled amplifiers? So if the pot got dirty over time and got crackle in it, with this Harris console, this really inexpensive one, you would hear this crackle, this as you turn it up and down, and sometimes you'd land at just the right spot where there was no left channel or no right channel. But the VCA overcame that problem by not being susceptible to the instantaneous vagaries in the individual potentiometer. There's usually a capacitor there too to kind of smooth things out. Hey, Chris Tarr, you worked on some of these older consoles that have these different designs of control?
Oh, sure. Well, I actually had an RCA just like you're talking about with the resistors on them. I love that thing. Although everybody keeps forgetting the step as you describe how these things work. It's, step, 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 wham, step, step. I mean, that's usually how those work.
So you're saying, they could have dirt on them and be totally disconnected at some point. Yeah,
right, and you'd have to kind of bang on it to get it to work, and that kind of thing. No, I mean, I've used from that all the way up to current digital technology, and I don't know that I really have one that I like better or worse, or that any one is easier to repair than another. I do know that there have been some that have just been a pain in the butt to take care of, but really, it's I think what's probably worse about a lot of these consoles is the age. They tend to have modifications made to them, and a lot of these modifications are non-factory modifications. And you go in and take a look at these things when they don't work, and you're trying to figure out what the heck was going on here. I have our current consoles at the station I'm at now, the Milwaukee stations. An enterprising engineer created an external headphone output that was not connected to the volume control on the console, but fed the same console audio to separate jacks. So he designed a circuit card that dropped into a slot on the console output, and it's tied into all these things. And I remember the first time I worked on it, I pulled the control out to clean it, and here's this little thing dangling from it with a couple of wires and a card. I tried to figure out what that is. But, you do find a lot of that over the years as people try to expand the capabilities of these consoles, some of these add-on things. But I'll tell you, it's a whole new world with digital consoles. I'm glad they're here because, some of these older consoles, are just, you try to work on them when somebody's trying to use them, and it can be a pain. But these new digital consoles are great for reconfiguring in a snap and that kind of thing.
Chris Tobin, you big city guy, you've never had to work on any of these cheaper consoles that didn't seem to have much quality built into them, did you?
Absolutely. I worked in places that were smaller operations but very successful, and we had I had a TV console built by Collins that used LDRs, the light dependent resistor package.
Oh, yeah.
Little
Oh,
silver
my
can.
goodness.
Yeah.
Yeah, that was the console surface. We'll call it the console surface in the studio, and in the rack room was the brains, the electronics, the audio amps, and that had relays that were mounted upside down inside the surface in the studio. So if you hit the console hard enough, they would pop out, and then you'd get full blast audio of that channel. And if
Chris,
that didn't,
you had this great story that's about. I think it's about those relays where you clip a wire and it just goes click 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 throughout the room.
Oh, that was when we were rebuilding. We were cleaning. We had just recently purchased a station, which did a lot of do-it-yourself workarounds from the manufacturer's design and very creative use of what we would call 25-pair cable used for a 1A2 phone system, 22 gauge.
Creative use of that.
Very creative use because during the story that Barry's going to have me tell you is I'm working as an assistant engineer to the folks, and they're saying, we're going to clear out the racks, just start cutting cables. Everything's been de-energized. The station's operating from a remote location, so the studios are offline. Everything's dead. Circuit breakers are turned off, so we thought. And I'm like, fine, great. Going through the racks, cutting cables, clearing out the equipment, take a pair of diagonals, and I take what looks like a 25-pair cable, nothing special. I cut that. Diagonals go flying out of my hand. They explode. Why? 120 volts going across the wires for use for apparently the on-air lights. Then, after I got back up on my feet after that incident, I went and cut another cable, and this was the fun cable. I'm sorry. You thought the electrical shock was the fun? No. This is even better. I cut this one cable, and it was like a TV show or, just a proverbial, what the heck just happened? Cut the wire. It slides down into a pipe, and it makes a sound like, bink, shing. You actually hear this whooshing sound. I'm like, what the devil? What was it? It had tension on it. It was like it's like a booby trap. I was like, great. I just set off a trap, and about 3 doors are going to come down on me. And then 20 seconds later, we start hearing beeping sounds. So the engineer and I are like, where's that coming from? I said, I think it's coming from everywhere. What? People are running throughout the radio station. Turns out that every phone in the radio station, this is an AM/FM combo, so you can imagine the number of phone sets we had, began beeping. Upon further investigation, it turns out that wire I cut was part of the alarm system, intruder alert. Apparently, I set off the intruder alert alarm, and it was designed to notify everybody in the radio station because there were times during automated hours, the FM was automated on overnights, that there may only be one person in the radio station in the building, so you had to make sure they could hear it. Needless to say, this was about 10 o'clock in the morning on a business day. Radio stations was purchased, trying to start a new format. People are chaotic and frenetic for that alone, and I've just set off the alarm. Oh, by the way, that I mentioned it was tied to an alarm service. You know what that means?
Oh, no.
Right. So, and let me add some more humor to this. And by the way, we were the tenants in a building that had 3 floors. We were on floor number 2. Floors number 1 and 3 were owned and operated by a bank. So not only did we set off the alarm to our office space, but we also off the alarm that's in our office space that's in a bank. So you can imagine what the folks were thinking when that alarm came into the alarm station and the address came up as a bank. Oh, yeah, that was fun.
Oh.
Yeah. And meanwhile, I'm the one in the phone closet trying to find out where this thing cross connects, which the phone closet in most places those days, was located in the common area just outside the entrance to the radio station. Yeah. So I opened up the door. There was a gentleman there with a firearm asking me to identify myself and make my hands visible. I'm like, whoa, hey, right, okay. It was great. It's true. This is true. This is like, wow, this was a baptism by fire. It's just, from then on in, I cut wires very carefully with little, vice grips on the bottom, and then I'd snip it. Where'd it go? Nothing. Good. All right, next. It was the wildest feeling. I mean, yeah, just,
you off topic like that, but that's one of my favorite stories of yours.
well, it's a classic. I mean, I just got the job. I'm working there. I'm like, okay, this is interesting. And to this day, when I talk to folks who I worked with at that place, we're still befuddled by where'd they wire this in? And it was just amazing. We did find the dialing apparatus and the stuff that called out to the police department and whatnot. It was located in a closet at the end of the hallway, in a part of the building we don't really use much, in the ceiling. So, this is like the feeling of working in a government facility. In the event that this place is overrun by, nefarious people, they won't find the device that'll alert the world that they've been taken over, because it's in the ceiling, in a closet, in a part of the building nobody uses. I mean, that's basically what it came down to. It was in a we were actually cleaning out this closet to move some equipment into, and I look up, I'm like, why is there a cable tie wrapped around that ceiling tile? I open it up, and sure enough, there's the mechanical dialer with a little disc, and it dials out, and I was like, oh boy, I'm pulling the power plug in this one right now.
Oh, that's just what they'd be expecting us to do.
Yeah.
Well, matter of fact, there's two dialers. That one was the dummy dialer. I just activated the trip.
I thought this was going to be Barry Thomas's war story, but no, this was definitely a Chris Tobin war story.
Those two guys have better stories than I do. I mean, my best story is taking apart one of the first consoles and then realizing the on-air light had been wired right 110 right to the on switch, and of course we all know how we found that out. Just geez,
Oh, well, yeah, I always wired them that. I always wired them that way, didn't you?
Oh,
I every radio station I worked at years ago when I was starting out, that was like common practice. By today's standards, you'd laugh, but back then, I'd say 1983, 84, that was common practice. 128 console, and part of the
right
wire
on the
was
key, right above the pot.
Yeah, well, there was this enormous key switch right there, and there's some extra contacts right there on it. Why not? And if we ran it through a relay, then we'd have to get a power supply and a relay. We can just plug the cord in for the lamp and take two of the wires and run them up to the console with the lamp cord and tie them onto that lever switch. What could be simpler, right?
Absolutely.
This junkies aren't supposed to be in there anyway.
From? Where's that hum I keep hearing?
I don't know why we didn't. I never had any hum from that. Should have. It was right there next to all the mixing bus wires. Literally the bus wires that went from one key switch to another key switch to another key switch.
But remember, the older consoles back in the day used shielded wire. I mean, real shield around those wires, and the voltage on those the power supplies was what, 48, 52 volts. Yeah. So the gain structure and design of those amplifiers. And you could pretty much run plus 35 and still have no distortion.
Have any of you guys ever worked on the Ampro boards, the old Ampro? They look like RCAs.
Oh, absolutely.
Oh, yes.
Didn't you love those tiny little bell wires that you you flip down the front and suddenly everything breaks apart and you've got to resolder the whole ladder pot?
I made so much money on Ampro consoles fixing them for this one station owner that thought they were just the cat's meow. I'm telling you, I fed my family for months on what I had to charge.
There's a reason they were out there. Do you guys remember Bill Tanner, the guy that basically sold you radio station equipment for trade?
Yes. Yeah.
He was an Ampro dealer. I ran into so many stations in the Southeast with piles of Ampro carts and stacks of Ampro boards.
Yeah.
And that was why. No cash, they could trade it.
This is for the stations that, for whatever reason, the owners of the stations could not accept hookers as payment. They wanted audio consoles, right?
Yeah, well, and that was before, independent record promoters started bringing other things as payment.
Yeah, okay, well, yeah.
Right.
Oh, my goodness. Barry, I had no idea, but yeah, there were stations in the Southeast that had the Ampro cart machines and consoles. Oh, man.
I was never so happy when my first ITC 99Bs came in there and I got to retire the Ampros in Columbia.
My goodness, what a difference.
Oh, you mean cart machines that actually worked?
Oh my
Well,
goodness.
except for here. I'll start off with the first. Well, not the first. I guess Chris Tobin did the first one. Here's a very short war story. So, the production people who did the commercials in the production room, they were complaining that you mentioned the ITC 99B. This is a cart machine that would prep the cart for you in every way. It would you put a cart in, you push up some button, and it would erase the cart. The cart eraser was built right into this thing. Now, remember, these cart machines don't have an erase head.
That
You had to
the
bolt
ELSA
erase them.
function. ELSA.
Yeah,
Yes,
the ELSA function. That's right. So it would erase it, and then it would locate the splice, because there was a splice in the continuous loop tape, right? And you didn't want to record the spot over the splice. So it would find the splice, and it would also align the heads. On a stereo machine, it would align the record head in case there were a little bit mechanical differences. So the playback head was fixed, and that was the reference, and it would adjust the record head to get the best frequency response and phase relationship. Well, there was, I think, an early production problem with these things where the erase coils that were built in just in the bottom of the deck, right next to the motor, I guess, right below where you put the cart in, these erase coils would not last a whole long time. But at one station, I found out why they weren't lasting more than a week. By the way, the idea was you put the cart in, you push the ELSA function, it does it, you walk away, go get a cup of coffee or whatever, and it sits there and does its thing. And when you come back, it is bulk erased, the record head is aligned, and it has found the splice and advanced the splice just past where you're going to start recording. Great, everything's fine so far. And at this point, you don't take the cart out, you now record on the cart because it's perfectly set up for that particular cart. Barry, do you have a couple carts there handy?
Hold on a second.
For the
Yes, I do.
For the few young whippersnappers in the audience, let's show them what a cart actually looks like.
This would be an
AA4?
audio pack, and this is a Scotch
Now,
cart.
hold it still now. You Skype
Bandwidth ain't everything. Okay. All right. So there's a couple of carts.
Move it out of the lower third here. There we go.
Yeah. So a continuous loop. It's tensioned inside. It has a hole in the bottom where the pinch roller comes up quickly and pulls the tape across the heads. All right. Cool. So that's what radio stations used for years for commercials and jingles and songs. So anyway,
It's about the size of an 8-track tape. In fact, that's almost the same case as an 8-track tape. You just take out the pinch roller. The machine would make the pinch roller come up in there.
Yeah. Yep. There you go. So okay, back to my short story that's turning out not to be as short as I thought. So you prepare the cart, and then you put it in record mode, and you record the cart. Whatever you're going to do, record on it. You record it right there. Well, production team said, hey, this thing's burning out. Really? Okay. So I said, show me what you're doing to prep the carts, after I had replaced the erase coil several times. And what they would do is they'd bring in a whole stack of carts, a whole stack of carts. 15, 20 carts, however, some 40-second carts, some 70-second carts, some 3.5 minute, 4.5, 5.5 minute carts, and they'd set them all right next to the machine. And then they would go to town erasing the carts. They'd pull a cart out, push it in, hit the ELSA button, let it do its thing, and then when it was done erasing, they'd pull it out and put the next cart in and erase that cart and pull it out and let it do its thing.
Absolutely.
And they do this to the whole stack. Well, okay, first of all, this means that the cart machine itself is aligned for the last cart they did. And it's not, not that there's a big difference, but it's not properly aligned for all the rest of the carts that they erased. And this poor little erase coil does have a duty cycle. They assume you're going to erase it and then use it and not just go erase something else. So this poor erase coil just kept burning out because they kept preparing one cart after another, after another, after another.
Do you remember how it smelled when they burned one up?
Oh, my goodness. Actually, I kind of like that smell. Isn't that weird?
Oh, that's just frightening.
Yeah. I like the smell of jet fuel, though, so, burned or unburned. Hey,
it was very similar to the smell of the Continental rectifiers after a lightning strike. When you walked into the transmitter room, lost a set of rectifiers.
Oh, yeah.
Oh, see, that's a very familiar smell.
Yeah, it is. Probably the worst smell, though, is when you grab the wrong end of the soldering iron. Oh. That is something awful. Speaking of smells, sorry. Hey, Mr. Tar,
Wow.
do you have a
How's it
story for
here?
us?
Wow. I don't know where to begin. Actually, I do, and it's a current story. I will preface this with it's not any of my stations. It's a contract job, and I won't. I'll protect the innocent by not saying the name. But I got a call about a week ago about this
Nunzio.
mom and pop AM station. And they said, yeah, our tower, it's a directional array, daytime or AM with a directional array. They said, one of our towers isn't working. And I said, okay, what led you down that path? Well, we had this engineer in here, and we're all worried because he said we need to get an STA and with the FCC, and that all these things were wrong. But we would like to have a second opinion, so we were wondering if you could come down. Okay, great. So I go down there. First of all, as I was driving to the radio station, went through and heard the null, drove through the null. So I went, okay, that's a directional station. I think both towers are working.
Okay.
So I get there and I walk through it, and sure enough, on the antenna monitor, one of the towers has readings, the other one has none. Okay, so I do a little investigating, and these very nicely designed ATUs, they still have the ammeters in there with the pull blades on them, so I can pull the blade, check the base current. Actually, the base current was okay for both towers. So I said, did anybody bother to check the sample lines? Maybe there's an issue there. So long story short, with that part of it, I found out that there's something wrong with the sample line. So I need to go take care of that. The transmitter was actually, both towers were actually functioning just fine. The part two of this is they said, well, the other thing is that it looks like the transmitter's shorting, and we're only able to make, like 180 watts out of 1,000. So, it's obviously the tower's shorted out. And I said, well, let's do a little digging. So I did a little digging, and this transmitter is a Gates 1, which is the successor to the SX5. I'm going to show you a part, and I think you're going to be able to figure out what's next. If you're familiar with the Gates or the SX5 series transmitters, or the SX series, they have these little transistors in the power modules, and they have a very nasty habit quite often of just shorting out, through lightning or whatever, and that causes the transmitter to not operate at full power and to have problems. So there's about 8 of these guys that were blown.
Yeah.
And so what I'm surmising after looking at the tower site and how the sample line looks connecting to the this is one of those sample loops where it's actually the toroid right inside the ATU. And the line going to the sample line that connects the sample line to the toroid is all charred. So I'm imagining they took one wallop of a lightning hit, but then unfortunately got some bad advice from a guy who came through. So what started out with, you need to come down because our tower is not working and our transmitter is dead, turned out to be 2 completely separate problems, but ones that you actually, you run into quite a bit. It just was funny because I replaced an SX5 recently, a couple years ago now, here in Milwaukee with a Nautel, and I swore up and down, oh, thank goodness I don't have to deal with these transmitters ever again. And the first thing I do when I open the door at this AM site, oh, hello, it's a Harris Gates 1. It's like, I'm telling you right now what I bet your problem is. I bet it's these. So,
Hey, for those who aren't watching, tell us what you're holding up there exactly. Tell us the nature of that part.
I am holding up. It's actually pretty common in the Gates and the SX5 or the SX series transmitters, an IRF 350 field effect transistor. And what this is it's a transmitter it's a transistor that goes into in the Gates series. It goes into the PDM boards, the modulator boards. In the SX series, they were used in the final amplifiers. And what happens is when these transistors are really sensitive to static and electrical pulses and things like that, and they tend to give up their life when a transmitter gets hit by lightning or has bad power issues, things like that. Pretty easy to fix. It takes all of a couple of minutes to replace these, but generally...
I hear these called FETs. Now, I always thought that was field effect transistor, but I really think that actually stands for fuse effect transistor.
Well, they
do that very well, actually. Yeah, they do that very well. So with this particular transmitter, I mean, it's a pretty common thing, and it shows very common symptoms. But it's actually to the point where I keep a lot of these spare because I run into so many transmitters that AM transmitters that take these. and they burn out. But that's kind of my war story. This place was a mess. You know, I had to sit down with the owners and explain that, you know, your EAS box has to work. You know, you need to make sure that people can't get to the site. We need to fix the transmitter so that it's working. So, you know, several things running into that. Unfortunately, I got most of their issues taken care of, and tomorrow I'll be heading out to take care of these problems here.
Hey, when you replace those transistors, do they always have a little sheet of mica or some other insulator between the case and whatever they're being soldered to? Or are there some designs where the case of the transistor does not need to be insulated from whatever it's being soldered onto or bolted to?
In all the designs I've seen, they all have the mica sheet. And so, you know, some of the boards, some of the older boards, you actually have to drop the bolt the transistor in and then solder it. The newer ones are socketed, so it's just a couple of bolts. And then you also have to make sure you bring thermal paste with you because they get hot. And in fact, you know, some of the fun things I've seen with these is, you know, I had one where the mica got old and cracked, and so the case shorted to the board and it started shooting flames as you turn the transmitter on. So the care and feeding of these they're very susceptible to shock, to electrostatic problems. So make sure, you know, you're grounded very well. Make sure you get a tube of the thermal paste. And so it's a sheet of mica, the thermal paste sheet of mica, and then bolt them right into the board. It's about a 5-minute job. By the way,
transmitter repair tip for you. Thermal repair paste is not the same thing as bathroom caulk.
Yeah, I call it schmutz. You give me the bottle of schmutz.
Schmutz. Oh gosh,
schmutz on it.
Another transmitter tip: make sure you know exactly where the Jesus stick is, because you know what they say. If you don't use it, you will see Jesus. Actually, there's another reason for it. If you haven't turned off all the breakers, you'll use it. Jesus.
Oh yes. Hey, one more quick question. The chat room is asking, well, hey, if they get hot and burn out, why not have a heat sink involved? But I'm thinking that a lot of these are mounted on heat sinks in the transmitter design.
Yeah, what they do is they have it's a combination for grounding and for heat sinking. A lot of these boards have a pretty heavy, thick section of copper that on a leg of them, and that's also schmutzed really well up against the transmitter. And then they also use blowers. So in a case where you do passive heating, you probably see heat sinks, but in this case, they actually have blower fans that blow air up over the transistors in the cabinet that they set.
Yeah, there's a lot of designs that use that transistor or transistors like them, that IRF 350. By the way, we have somebody who works for IR in the chat room. That's kind of interesting. And so, yeah, some designs call for heatsink, others call for a circuit board with a big bunch of copper already on it. And so they're designed for proper thermal dissipation. So it's not just the fact that they run warm or even hot. In fact, I guess most of these transmitters, I've shut them down, and after using the Jesus stick, I've gone inside and just, you know, one thing you can do is touch the transistor. And hey, if a bunch of them are warm, the same temperature, and a couple of them are cold, well, you can pretty well guess that those two aren't doing their job. Or if a bunch of them are warm and two of them are lightning blazing hot, it might be shorted out and passing a lot of current and really not doing much good in the circuit. So, hey, simple troubleshooting tip there. Sometimes, you know, be careful, don't burn yourself, but sometimes you can just see what's wrong by seeing what's hot and what's not.
And they don't get, if they're getting really hot, there's a problem. I mean, they get warm.
Yeah. Hey, guys, we're going to take a quick pause here and hear from our sponsor, which is Omnia Audio. When we come back, two major things. We're going to have more war stories. I'm sure Barry Thomas, we've not hardly let get a word in edgewise here in the last few minutes, is going to tell us one of his favorite war stories. And before the show ends, somebody's going to remind me to give away that Omnia AXE license from the folks who retweeted the show. Thank you very, very much. But right now, I want to mention to you our sponsor, Omnia Audio, and the forthcoming Omnia 9 audio processor. And Burke, I sent you a link, and I think you're going to probably pop that puppy right up there. The Omnia 9, hey, I just last week, or week before last, no, was it last? Yeah, early last week, that's when I was. I got to go to Amsterdam, to the IBC show in Amsterdam, and got to spend some time with both Cornelius Gould, Corny, who's been a guest on this show, and Leif Clayson, who's been a guest on this show as well. Leif is the designer of the Omnia 9 audio processor for FM. But it's not just for FM. The Omnia 9 has this feature list that is just as long as your arm. It does all kinds of things that you might want to do around a radio station. Let me go over a couple of these features with you. All these features are inside this single 3RU box. It can simultaneously do separate processing for FM and HD and HD2 and HD3. Each processing core is separately fully adjustable, has selectable 4, 5, 6, or 7 band processing. Pick whatever you like for the style of processing that you want to do. When in the stereo generator portion of it, it has this really cool thing that Leif has invented. It's a psychoacoustic composite embedder. And this composite embedder allows up to 140% audio peaks in stereo while maintaining 100% total modulation. It's this really cool scheme for embedding composite material in the FM composite scheme. It also has this really cool undo technology. This is a source declipping algorithm, and it's a program adaptive multi-band expander. So this removes distortion from source material that's been clipped. And it corrects overprocessed CDs as well. These are pretty common in today's contemporary music. I've seen this work. I've heard it work. It is dramatic what it can do to clean up CDs that are dirty, overprocessed, and that even sound even worse when they go through traditional audio processors. Plus, there's a 3-stage wideband AGC. It's got adjustable sidechain equalization. There's multiband downward expansion that reduces source noise if that's what you need to do. It has program-dependent multiband compression. It's on and on and on. These features go on and on, including an RDS encoder. Hey, you can save money by not having to buy a separate one. Use the RDS encoder that's built into the Omnia 9. And there's this new thing that's just been approved by the FCC on an experimental basis, and that is single sideband stereo encoding. Back on our show here on TWiRT, when we explained frequency modulation and how stereo works, there's this subcarrier. It's the left minus right subcarrier, and it's this double sideband suppressed carrier subcarrier that carries the left minus right information. Well, guess what? It's possible to transmit only half of that, the lower sideband, and almost all FM receivers will use that just fine and decode right back into the left and right stereo. The benefit is there's less chance for multipath distortion to occur in the decoded audio because you're not going so far up in frequency on the baseband. There's a white paper on the Omnia website about how that works. Check it out. If you would, go to omniaaudio.com/9. That's the number 9. omniaudio.com/9. Also, not sure if they're posted yet, but we've got some new videos from Leif Clayson where he describes some of the processes and the functions inside the Omnia 9. Check it out, omniaudio.com/9. And I thank Omnia Audio for sponsoring the show. By the way, we're going to start shipping Omnia 9s from Omnia within the next, I want to say, about 5 weeks. They are on the benches now, being built, and Leif just has to give them a once-over and a blessing, and the first ones will be out the door. So contact your dealer, get yours on order, and I think you're going to enjoy it. All right, gentlemen, on with war stories on This Week in Radio Tech. Mr. Barry Thomas, let's go to you, and let's talk about your war story. You got a favorite thing to tell us, something we can learn from, something where you almost hurt yourself that we can learn from so we don't do the same thing?
Yeah, I was trying to think, well, which one can I pull from? Can I, the 16-day radio station move, the, oh my God, we lost our lease, we've got to get out of here move, any number of these. But when Chris was talking about the transmitter thing, it made me think about a transmitter that I know you've worked with, Kirk, and I'm pretty sure you have, you've worked with these too, both Chris's, is the Harris FM 20K or the 20H3.
I've got one.
Yes.
They have a very distinct sound. Let's see if it comes out over here. This is how I'm making the sound. Yes, a yardstick. But they make a sound.
It brings back memories.
Oh, yeah. It's not resonant enough, though. It's not, the walls aren't shattering when you do that.
Right. So, but is that not exactly the sound?
Yes.
Absolutely.
Yes.
And what it is the Harris 20H series. It was a half-wave tube cavity the whole back of the tube cavity would come off so you could change the tube. And it was a vacuum tube that was about that big around, this deep, and it was mostly ceramic. And but because it was such a large piece of metal, the entire back, it would develop a significant amount of circulating current, especially in the very middle of it where there was the least amount of tension for that door. So after a while, air pressure, because it was under positive pressure, would build up, and one spot in the middle would start arcing, and that's what would make that noise. But you always knew you were working on a Harris FM20 because you'd tune it and it would make this noise. But it was okay. You were still on the air. One of my favorite. So I actually have two war stories about this. My favorite is whenever I would get a new intern at the radio station, I'd say, "Oh, come on, come out to the transmitter site with me. I'll show you what's out there. We got this 1,000-foot tower. We got it's a 100,000-watt radio station. You can see all this nice stuff. Here's our new Optimod. Here's our our backup, which is there's a rock solid FM RCA BTF 10E1, really great transmitter there. And there's our at the time new FM20." I say, "But I need you to help me. I need you to go behind and look at that breaker box. It's right behind the wall over here," and it was right behind the transmitter. And all I do was just tweak the loading a little bit, and where they would be standing to watch that breaker would be right beside where that sound would come out, and it would do that. And so help me, I think I took years off of these kids' lives, but I had so much fun. But one of our part-timers, the second part of that story, was one of our part-timers was a former Harris field tech. Rick Stevens was his name, and what he liked to do was when he knew some of his friends were on the phone line handling the 24-hour service, was it help me out here, 217-822-2222, I believe is what it was. But it was the Harris FM field service, always someone there 24 hours a day to take care of help you with transmitter problems. But if one of his friends was on there, he would call up and use whatever language or accent, and he would say, "Oh, I just hit I hit the power switch, and it just and he said, "No, please sir, stop doing that. Tell me what the readings say." And finally end up with the guy the poor Harris 24-hour service tech in tears, because all he can hear is this transmitter going until finally we all fall over laughing, and the guy just starts cussing at us because we know that Rick just called him again. So, those weren't risks of my life, but those were just fond memories of radio.
Gosh.
Of course, there were those times when you were tuning those transmitters where it would go whack, 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 wham, and then shut down.
But the thing was, the best time of my life was when I finally figured out why it would do that, and figured out how to make it never happen again. And it took maintenance, and it took understanding what the problem was. I'm going to set my yardstick down. It took understanding why the problem was, and that's probably one of the first really good lessons I got in the craft of broadcast engineering, understanding circulating current and pressures, and then understanding what we can do to fix it. The funny thing is once I learned how to make this particular transmitter not make that noise, the efficiency of that transmitter started working a lot better, because the tuned cavity was working in a consistent way. So that was actually a good upside and a good learning experience, but it was a whole lot of fun too.
Did you ever feel at risk when this arcing was going on?
It did it so often. You just, for a while there, as particularly when the chief engineer that was my boss when we put it in, he just took it as a given. He just said, "Well, this is just what the transmitter does." That's not true. It didn't have to do that. It was, you had to mind your P's and Q's, and you could figure out what the problem was. But that was one of the early signs that it was dirty and just needed to be cleaned, or the back door had taken a lightning strike and it wasn't holding a good, good pressure anymore, or something else was wrong. But like Chris said, it would sometimes go just bam, bam, and that would be, the screen arcing over or the screen supply blowing up inside there, and some real damage would happen. The one other thing about that transmitter particularly is it had, when it cut on the high voltage power, because these transmitters, and I'm going to, sorry for those who know this transmitter, but these transmitters operated at about, 10,000 volts at 2.5, 3.5 amps. So it's a significant amount of current to create about 15,000 watts. These are FM transmitters I'm talking about.
Yeah.
So you would warm up the tube with a filament supply. So it would be warm, it would be ready, and then you turn on the high voltage, and that would be turning on the plates, engaging the plate supply, and that would be turning on the 10,000 volts, or the 7,500 volts in this case. But the thing was, this transmitter only switched 2 of 3 phases to make that 10,000 volts. Mm-hmm. There wasn't a 3-phase contactors, because 3-phase relays are very expensive, but 2-phase relays you can get. So if you open up this transmitter, you look at it, you see here's these big fat wires coming in with these wires coming in to feed the rectifier, to feed the supply. 2 of them go to a giant relay, and then one just goes to a glass insulator with a bolt on top. Oh. So that was where I learned about the Jesus stick, because I had turned off everything, but I didn't turn off the breaker on the wall, didn't turn off the knife switch on the wall. Hey, it was off, I could do it. So I bring out the little stick, and I'm touching it in there. Okay, caps are all undone, and I touch this one little bolt on a piece of glass. Pow! Okay. I guess the breaker's blown now. But that was where I learned, that was a manufacturing cost decision to make it an accessible purchase. We're not going to put in a $200 3-phase contactor. We'll put in a $45 2-phase contactor.
So aside from the manufacturing implications, what did you learn from that? And did you change your behavior in the future?
Oh, absolutely. That big knife switch that was over my left-hand shoulder at the time, that was always off. Electricians used to have a bumper sticker that says, it ain't dead if it ain't grounded. And that is just the absolute truth. You've got to kill the power, double check that you kill the power, ground it, and better yet, have someone over your shoulder to make sure you've done it right.
It's funny. A lot of us have kind of learned that way. I told the war story once about the FM 2.5K I was working on that I thought I had killed the power on, and was in there working right above the transformer, and realized after I went to turn the plate on to get it ready for power, because if you turn the switch into auto, it would automatically start up. When I hit that switch and the transmitter came on, and I realized the whole time I hadn't killed power to it, that was the thing for me, where all of a sudden after that I just needed that to happen, and I've never had that issue again. It seems like that's a kind of a common thread, especially with young engineers, which is why if you're just getting into this, listen to what we're saying. You just never know where that power is going to be.
Chris, do you remember what tube that FM 2.5K used?
1500.
It's a 5CX 1500
A. A.
Yeah.
Yes.
Reason I mentioned that is that tube had toroid chokes inside the vacuum. So you pull it out, and you say you're getting ready to change it. You take it, and if you tilted it slightly, it would rattle. So you'd like, oh, I found a bad tube. Okay, you set it back there. You go into the other room. You pick up the new tube.
They all rattle.
This one's rattling too. I think I opened up 3 different tubes, and these things are not cheap. But some poor station, I was so confused that I'm not going to put it in this tube. It rattles.
Wow.
Yeah,
So,
some kindly engineer took pity on me and says, no, those are chokes. Those are supposed to do that.
but would it kill them to put a note on the tube packaging? By the way, if this rattles, doesn't mean it's bad. Would it kill them?
I think they would assume that a certain amount of skill would be involved if you were going to be handling an FM transmitting vacuum tube.
Hey, speaking of vacuum tubes, and earlier you were talking about some bigger Harris transmitters, and you were referring to the FM 20K series and like that.
Yeah, and that used a 4CX 15,000C.
Yeah, was there a maybe not in that transmitter, but wasn't there a Harris transmitter that came after that? I'm thinking this would have been in the early to mid 90s. Seems like there was
a 25K.
Okay, but what was there a letter after the K?
There's the HT20.
That's like late 90s, yeah.
Maybe that's it. But it seems like there was for certain frequencies, so that the size of everything kind of changes in there depending. But it seems like there was a transmitter that they made, that Harris made, that to put the tube in, you had to like shove it in the chimney upside down, and then while it was in that position, flip it around so that the base was then down, and then it would go down. But you couldn't put it just in the way you'd think it would go in. It wouldn't fit
they started they started that with a 25K, and the reason for that was because of that whacking noise. They went with a quarter wave cavity, and if you've got a quarter wave cavity, they could no longer make the whole back of the cavity come off. They were going because it so significantly changes the tuning of the circuit. So you want to make that door as small as possible. So you just couldn't fit the tube through there. So you ended up having to the book had, in fact, I probably even have the manual over there. There's a procedure of twirling it in and setting it down, and then picking it up, twirling it, and shoehorning it out.
It's like ballet with a $2,000 tube.
Yeah.
And don't forget, if you don't cut yourself and bleed, then you're not working on a Harris product.
That's true. and the thing about those 25Ks too, while you were twirling, you couldn't touch the chimney because the chimney was part of the circuit. There was a Kapton sheet, and the chimney was the plate blocking capacity.
Yeah.
If you broke that, you just caused yourself hours and hours. That's if you have Kapton sheets handy. You just caused yourself hours and hours of off-air time.
It was a fine art. Pirouettes and twirling was what you had to learn to do at 2 o'clock in the morning on an FM 25.
Yeah.
A true balancing act.
We've gone about an hour, and we've each given a little war story, and I'll tell you, this hour has just flown by. Barry, I'm very glad that you came on the show. Thank you for joining us, and would you come back sometime?
Sure, I'll be glad to. But I have to make one more comment.
Please do.
Chris, both Chris's. You may think that I'm sitting in a radio station. No, I'm much sadder than that. This is my house.
That's quite all right. I have a friend of mine has a similar looking situation in his studio at home as well. Not a problem.
Yeah.
You know what? And honestly, I wouldn't feel bad because I'm jealous.
Absolutely.
Try to keep this thing running.
Hey, we should answer the chat room's question. What console is that behind you, Barry?
That is a PRNE ABX. It's a multi-track console, but I don't have the groups in it. This was originally at WQXI here in Atlanta and WSTR. But it's a still running, still in great shape ABX. But you just don't need this much, this much hardware to do radio nowadays.
Man, that is a whole lot of hardware. Yeah. Wow.
You're only seeing half of it.
Yeah, I know.
There's another half that goes this way.
Earlier today, Barry, you were giving me the tour of that room, and what you've got some honking turntables in there with some Technics SP somethings.
Yeah, I got a pair of SP15s underneath here that I'll just barely crack it underneath there, and then this is the Technics 1200 CD player. That's all
a classic.
These are old antiques. Yeah, they are. It needs some tweaking. No one can do any alignment on these things anymore. Way back up there, if you recognize the screen, that's an Enco workstation. Yeah, and through that door is my shop. And believe it or not, it's a real with the bench and everything. So for some reason, my wife endures it as long as she doesn't have to see it.
Actually, my next question was going to be, surely, to goodness, Barry, you have kept this room secret from your wife. Otherwise, it wouldn't exist.
She has the other half of the basement, and she just prefers not to be here. But what she likes to do is if there's something I admire, say at an antique store, and she's want to say, "Gee, that would look really good in your studio."
We know where she's going.
Yeah.
That's great. Oh, man. Hey, guys, we do have to draw this to a close. I want to thank my co-host, Chris Tobin from Manhattan, New York City, the best-dressed engineer in radio. Well, I'm going to have to find a different way to introduce you, I suppose.
That's okay. There's nothing wrong with that. I just want to make sure I say one thing.
Yes, sir.
I was at the CCBE. Let me see if I get this right. Okay, it's a regional engineering convention up in Toronto, Canada, and met two of our viewers and listeners. One of the gentlemen's name is Dave Simon from CTV. Another gentleman's name, I believe, is Wally. I didn't have a card, but he's from CFRB Radio. So I just told him I would say thank you for listening and tuning in, supporting us. And I just wanted to make sure the CCBE is a great event. If you have a chance to attend it, sort of like a regional SBE you would attend here in the States, and very, very, a lot of fun up in Toronto. Just throwing that in for engineering purposes.
And by the way, I want to thank CCB for inviting me to go up there, and I just didn't get a chance to this year. I've been there like 2 or 3 times, and I'm glad you got to go, Chris, and maybe we'll get to end up going together next year. I'll see you up there if you go next year.
Absolutely. I'm planning on it. I'm going to plan to go. It was a great event for both for the engineering papers and just to be able to socialize with folks in an environment that just made sense. I mean, it really, for regional shows, that's the way to do it. It was ideal, I have to say.
And also with us from Mukwonago, Wisconsin, out in the real world where reality television is filmed, it's Chris Tarr. Thank you for being with us, Chris.
Oh, you're welcome. Yeah, I think the next show is going to be something about cows and beer, I'm sure, the reality show. Cows getting drunk or something.
Oh, jeez. And our guest, Barry Thomas. I've known Barry Thomas for years and so thankful. And Barry and I, we only see each other at NAB shows. That's the only time we get to cross paths. But we always have some stories to tell, and it's always good to see you. Barry, thanks for coming on our show, and we hope you'll come back sometime.
I hope to as well. I'd like to also invite all of your listeners for next week. The Society of Broadcast Engineers National Meeting is being held in Columbus, Ohio, in association with the Ohio Association of Broadcasters Conference. So go to sbe.org to learn more about that, and hope to come back and see you again.
By the way, I'm not going to be there. Jim Armstrong will be there from Telos, and I think that my employer, Telos, is actually sponsoring the dinner up there on a week from tonight.
And Manny Centeno from FEMA will be our featured speaker for that dinner. Thank you so much.
That's right. That's right. Oh, and there will be a door prize. We're giving away a Telos Zephyr, a Zip 1 will be the door prize at that dinner. So if you were on the fence about going to that dinner, get your act together and get your tickets and go to that SBE awards dinner a week from tonight. All right.
Great. No, I'm still busy retweeting.
Okay. Oh, we got to pick a winner. Oh, yes. Barry, let's see. I was counting up the number of retweets here. Give me a single-digit number. Give me a 1 to 10 number.
8.
Off the top of your head. 8?
8. Yeah.
8. Okay, hang on a second. 1, 2, 3, 4, 5, 6, 7, and 8. And we come up with the winner of the Omnia AXE goes by the Twitter handle of The Mark Show. That's M-A-R-C. The Mark Show. All right, The Mark Show. The Mark Show. We'll be in touch, and we'll get you your free Omnia AXE. Thanks for retweeting. Thanks to everyone who retweeted. Yay. Thanks to everyone, including Burke back at the Petaluma for switching the show. Appreciate you very much, Burke. And we'll be back for another episode number 101. We'll start with in the 100s now that we've done. Yeah, we've done 100 shows. We start with number 1. We have 100. Yeah, we didn't start with 0. We started with 1. And we'll be back next time with show number 101. Thanks for being with us. Thanks to Omnia for sponsoring our show. And we'll see you next week on This Week in Radio Tech. Bye-bye.